Okay, let's talk about sets. So a set is really just a group of objects that are similar. Okay, so a group of objects that are similar. Notice that doesn't say anything about mathematical things, right? That are similar. We could have, well, the Baker family, right? There's Mr. Baker, really tall, and Mrs. Baker. And let's see, I have a daughter and a son with glasses, and a little baby who's growling. Okay, these are five objects, if you will, five things that are similar. So this would be called the set of, I could call it the set of Mr. Baker, of the Bakers, right? The set of the Bakers. And the objects, also known as the elements, within this set are, there's five of them. Mr. Baker, Mrs. Baker, Evie, Callan, and Benjamin Baker. Okay, and they are similar because they are all in the same family. Okay, I could have a set of Mexican food. All right, so this set, let's call it M, because in math we like to abbreviate things. I could call it the set of Mexican food consists of all the different kinds of Mexican food. Some notation you'll see sometimes in sets, we put this little curly bracket. That just means I'm going to start listing the elements or the members or the objects in this group. Here they come. Ready? So tacos, burritos, enchiladas. I'm getting hungry. I haven't had dinner yet. It's like 6:30 at night. Enchiladas, burritos, tacos. What else we got? Tamales. Okay. You can keep going on for a long time. This would be so this set is the set M of all Mexican foods, and it consists of tacos, burritos, enchiladas, tamales, and other things. Okay, so this is sets, and this is set notation. So again, we put these little brackets. In fact, I could put a little brackets around my family, and we separate them with commas, showing you what belongs inside that set. All right, let's talk about sets of numbers. So, actually, before we get into that, I'll do a different video on the sets of numbers. Let's talk about another couple of things about sets. Take a look at the set of Mexican food. Okay, if I make another set of, let's say, let me add a couple of things to my set of Mexican food here. Okay, so I could say, let's see, what else is Mexican food? Beans, rice. Okay, we'll keep going for a little bit. Now I'm going to set a set of Chinese food. And we'll call that C. C for Chinese, right? If I list my objects that are within the set C of Chinese food, that would just be all the different kinds of Chinese food. So maybe I have, let's see, boy, I haven't thought about this one. Egg drop soup, chow mein, and what else do they have? Well, I'm getting as rice. They also have rice in Chinese food, right? Kung Pao chicken, and on. Okay, so you can see I have a couple sets here. I have a set of Chinese food and I have a set of Mexican food. M for Mexican and C for Chinese. Now, let's take a look at this. Are there any objects that are in my set M, Mexican food, that are also in my set C, Chinese food? Yeah, there is, right? There's rice. Both Chinese food and Mexican food have rice in them often. Okay, so what this means is if I draw a picture of my two sets, they overlap, don't they? There's one food that's in both the Chinese and the Mexican food. So if I drew a picture of this, it would look something like this, right? I could draw. Here's my table. Maybe here's my here's a store I go to buy food. This is Walmart, maybe, right? This is HEB. Okay, and inside this store has all the foods possible. Okay, it has everything you can imagine, right? This is a super HEB. It has everything that you could buy this food. And in one little section here, it has um, Mexican food. Okay, in one section has Mexican food. You go right over there to buy all your tamales and your enchiladas and all that yummy stuff. In another section over here, it has Chinese food. Okay, that's Chinese food over there. Now you'll notice that there's a little area between here where the Chinese food and the Mexican food, the aisles cross. And guess what you find in that aisle right there? Guess what you find? You find rice, right? You find the rice. So over here you'll find the enchiladas, and over here you will see the kung pao chicken. But in the middle, and shared by both those two sets, is rice. Okay, so this right here, what I just drew, you've probably seen it before. This is called a Venn diagram. It's a way of showing that how members of a set relate to each other and how different sets relate to each other. So you can see right here, you can look at it, you can tell right away that both of these sets are have food, right? They belong to this really big set. You could call it the set of all foods, right? That's HEB plus. We call that set H for HEB, right? And you can also see that most of the foods are different. So all these foods here, the Mexican foods, are different from all these Chinese foods. They're different. You eat different things in Mexico than you eat in chicken, China. But you can also see that there is a certain part that's shared between the Chinese food and the Mexican food. Okay, so that's what this Venn diagram is really good at showing us. It also looks like a MasterCard emblem right there. Okay, now let's show you one more. So I'm going to do a set. Let's say, oh boy, here. Let's do this one. Okay, a set of. I'm going to call it. Let's say set A. Okay, set A, which is the it's the animals from Africa, right? Animals. Actually, I'm going to change that. It's the animals inside the Victoria Zoo. Have you been there yet? It's pretty cool. Texas Zoo. And the Texas Zoo in Victoria. Okay, I took my kids there a couple months ago, actually during the summer. They enjoyed it a lot. It was really fun. Animals in the Texas Zoo in Victoria. Okay. Now I have set. Now I kind of want to change that. That's okay. We'll call it set B for birds. Okay, so set B is all the different kinds of birds. So again, if we drew these two things, I could draw it inside of one really big rectangle, right? What do they have in common? Well, these are animals and these are animals. So I could say this is all the animals in the world. And over here I have these are all the animals in the zoo, right? Set A is the zoo. Over here I have all the different animals that are birds, and then there's some that overlap, right? So the Texas Zoo has some different. They have peacocks there, which are birds. They have this is the overlap. Okay, I'm sure they have other things. I'm trying to remember. I don't think they have penguins. Maybe they do, but every bird that they do have would be inside here, and all the birds that they don't have, maybe they don't have penguins. If they didn't have penguins, it'd be over here. They probably don't have. I don't know, bald eagle. I don't think they have a bald eagle. That would be over here. And then the animals they do have that aren't birds would be over here. So, example, I think they had turtles and snakes and hippopotamus. Those would be animals in the zoo, but that aren't birds. Okay. And one more example before we're done, just to kind of shake things up. This is also a Venn diagram. Okay, last one. All right. Here's one I want to do. This is a set. We'll call it set. I'm just going to call it different letters. I'm going to call it set X. All right. Set X is all the children in the world who have pets. Okay, so you can imagine you go around the world, you get all the people with pets, and you put them in this big, really big room together. Okay, and set Y are all the children in the world with dogs. Okay, now right away I want to ask you the question: which set is going to be bigger? In other words, which set is going to have more members or elements or objects or children inside of it? The one that's children with pets or the one that's children with dogs? Okay. Well, you can imagine. I can draw a picture. Let's see. First of all, my box might just be all the children in the world. Okay, because that's what they have in common. They're both children. Now, Which is going to be bigger? Well, the children with pets, right? There's more people with pets than there are people with dogs. So here is a circle representing the children with pets. That's sex. Set X. Oh boy, little blooper there. You guys will enjoy. All right, this is the children with pets. Now, real quick, are there children who have pets who don't have dogs? Could you have a pet but not have a dog? Yeah, sure. You can have a cat or a canary or hippopotamus, I suppose. Now, are there children though? Are there children who have dogs who don't have pets? Well, I guess you could debate it, but I'm going to say no. If you have a dog, by definition, a dog is a kind of pet. So I'm not going to draw it overlapping. Imagine if I drew it overlapping like this, right? If I drew that part over here, these kids over here would be people with dogs but without pets. They don't exist. There's nobody with a dog that doesn't have a pet, right? If you have a dog, you have a pet. So really, it doesn't overlap. It just becomes part of it. Okay, so this would be why dogs. The children with dogs. Okay, so Venn diagrams, they don't always overlap. And if I redraw this, I could draw this, or I could draw this. Remember, the shapes doesn't really matter. You can draw triangles, circles, squares, doesn't matter. What matters is the relationship, whether they're overlapping, whether one's inside of the other one. So I could draw this again as here's the pets, and within that is the dogs. Right? That shows you that dogs are kind of pet. And you can imagine there's people here who have dogs. Hi, dude. And you can ask him, okay, do you have a pet? He'd say, of course I do. I have a dog. I just told you that, right? Is he inside the dog circle? Yes. Is he inside the pet circle? Yeah, of course. All right. You can imagine there are people over here. You say, okay, bud, do you have a dog? He says, no. But do you have a pet? Yes, I have a cat. Right? So he's in the pet circle, but he's not in the dog circle. And you can imagine somebody out here say, all right, Johnny, do you have a dog? No. Do you have a pet? No. Oh, I'm sorry, Johnny. Oh, that's horrible. Maybe for Christmas you'll get something. All right. So that sets. Look, we didn't even talk about math. I mean, we kind of did. We defined some terms, but sets just means something has in common. All the kids in the world who have pets have something in common, don't they? All the animals in the Victoria Zoo, they have something in common. All right. A set is just a collection or a group of things that have some similarity between them. And we've seen Venn diagrams. Venn diagrams show you whether sets overlap, whether there's something that's, both a Chinese food and a Mexican food. They show you whether, I mean, sometimes you might have two sets that are completely different, right? So here's a set of boys, and here's a set of girls. And generally speaking, if you're a boy, you're not a girl, and vice versa, right? They don't overlap. They're just completely separate. Okay, so that would be a Venn diagram as well. So Venn diagrams, they can overlap, showing that there's some similarity. There's some things that are shared. They can be completely separate, showing that they're totally different. Or they can have one thing inside of another, which is, by the way, we'll need to know this too, is called a subset. It's kind of like the movie Inception, which you probably shouldn't have seen yet because it's PG-13. But in this movie, there's this guy who they infiltrate people's dreams. So you dream that you're dreaming that you're dreaming that you're dreaming. I hate those dreams myself because I always wake up and I'm not sure if I'm awake yet. Right? Am I still sleeping? Am I awake? Right? Did I miss school? Whatever. But so a set within a set is called a subset. So people with dogs is a subset of people with pets, right? Because that set of people with dogs is completely inside of the set of people with pets. All right, and that's it for this video. See you for the next one.